Hey guys, today I'd like to show you something that I built a while back. This, a Jacob's ladder built with a microwave oven transformer. So as you can see, when I bridge the gap between the two copper wires, a ball of ionized gas rises up the Jacob's ladder. Now before I get into how this Jacob's ladder works, I'd like to give a brief safety note. So I hate to use the cliche line, don't try this at home, but it's probably not the best idea. But rest assured, tons of safety precautions were taken throughout this entire video. Whenever the transformer is not in use, it's always unplugged. I'm always wearing these thick gloves to help insulate me, in addition to holding this wooden stick, which also insulates me as well. I always got rubber-soled shoes on, and of course, I'm always wearing my safety shades. Now with that being said, let's figure out how this bad boy works. Now the physics behind the Jacob's ladder itself is pretty simple. This first wire right here is hooked up to the transformer itself, and it is sending a beam of electrons to this wire. But they want to jump from this first wire to the second wire, which is hooked up to ground, but they can't quite bridge that gap unless I bridge it for them using this nail right here. And you see, this gets really hot, and as hot air rises, it rises up and goes all the way to the top until it stops. Now this electricity is heating up the air so much, it is turning into plasma. Now if you try to use a Jacob's ladder with just the standard 110 volts as I have right now, as you can see, it just doesn't work. To make it really work, we need a lot more voltage. And to do that, we need this big chunk of metal, which is a transformer. This transformer I salvaged from a microwave that I found on the side of the road. And this can convert 110 volts from a normal power outlet into over 2,000 volts, which is more than enough to power this Jacob's ladder, as you just saw. The way transformers work is based on one really cool principle of physics, and that is that every single wire that has an electrical current passing through it will produce its own magnetic field. So this wire right here, if it had a current running through it, would produce its own magnetic field, but it wouldn't be that strong. But if I were to wrap it around and create two turns, I would effectively double its magnetic field. And this is how we get electromagnets, like this one I made from just wrapping some copper wire around a bolt. And this has many turns, so it can get fairly strong. But with transformers, we have huge chunks of metal and huge strands of copper that are wrapped around many times, and these can produce really strong magnetic currents. If we take a close look at this transformer, we can see that there are two coils. There's a primary coil down here, and there's a secondary coil up here. Now, the job of the primary coil is to take an electrical current and convert it into a magnetic field. And the job of the secondary coil up top is to take that magnetic field and convert that back into electrical currents. Now, separating these two coils is an iron core, which is a much better job at conducting magnetic fields than air would. Now, there are two kinds of transformers, step-up and step-down transformers. So a phone charging brick is a good example of a step-down transformer. It takes 110 volts from the wall and converts it to 5 volts to be used by your phone. And in this case, the primary coil will have more turns than the secondary coil. The microwave oven transformer you've seen this entire video is an example of a step-up transformer. It takes 110 volts from the wall and converts it to over 2,000 volts. And as we can see, it has fewer turns in its primary coil than its secondary coil. And this means that's going to step up the power. In the step-down transformer, the amperage goes up, even though the voltage goes down. And the step-up transformer, the amperage goes down while the voltage goes up, which is really important for making the Jacob's ladder work properly. Thank you so much for watching. If you enjoyed watching this video as much as I enjoyed creating this video, then please leave a like or subscribe. Thanks. And this spark is heating up the air a ton, and it is creating plasma. And the breaker just tripped.